Alright, so we'll be looking at proving or verifying a trigonometric identity. Verifying comes from the Latin word for truth. So if you verify something, you are proving that it is true, you are showing that it is true. Proving something, again, you're showing that it's true. And the big difference here is that instead of just having an expression, we are going to have an equation. So tangent theta plus cotangent of theta divided by tangent of theta is equal to cosecant squared theta. So notice here we have an equation, whereas in the other ones that y'all just videoed, those were only expressions. Now, algebraically, when we have an equation, we do things to both sides of the equation. But here, okay, we want to work on only one side of the equation. So it's not like algebra where you multiply by 5 on the left and multiply by 5 on the right. We're just going to take one side of the equation and transform it until it equals the other side. So in essence, it's like we didn't even have this, and we are simplifying this until it equals cosecant squared theta. So that's why you'll see there's only going to be one example, because it's very much like what you just did. Alright, so we're going to use those same strategies, which is factor if you can. Oh, but we can't. Look for squares. Oh, I don't see any. Replace cosine and sine. Yeah, we could do that for sure. But actually, there's just something else that's kind of inviting to me. Do you see I have this numerator over this denominator? So instead of like having two fractions where I get the common denominator, it's like I've already got the common denominator, and what if I broke this into two fractions? And the only reason that it is inviting me to do that is because tangent over tangent is going to equal 1. 1 is pretty simple. So I'm going to try that route. Sometimes when you're doing these, you try something and it just reaches a dead end and you have to go back and try again. So all I did was break this numerator into two fractions. And again, that's not the thing that you might typically do, but tangent over tangent is 1, and that's kind of inviting. So tangent over tangent is 1, so I'm going to bring down my 1. Now, cotangent and tangent are related to each other. They're actually reciprocals of each other. So I'm thinking turning one into the other is probably a good idea, right? Like I don't want to change both of them. So I'm actually going to look at cosecant squared theta and kind of in my mind work backwards a little bit. So if I go to my formula chart and I look on my Pythagorean identities, and I'm driven to do that because of the squared, right? Oh, look right here. Cosecant squared theta is equal to 1 plus cotangent squared theta. I already have a 1. Let me see what happens if I put everything in terms of cotangent. Alright, let's see. 1 plus, I'm going to leave the cotangent right there. Tangent is the reciprocal of cotangent. So right here, tangent of theta is 1 over cotangent. So I'm going to put 1 over cotangent theta. if the colors help you guys, this is the part that changed. Tangent theta was replaced with its reciprocal. So now all I'm going to do is carry out this division. To divide means to multiply by the reciprocal of the divisor. So take this divisor and turn it into its reciprocal, flip it. So then that's 1 plus cotangent times cotangent is cotangent squared. Look at my Pythagorean. Cotangent squared plus 1. 1 plus cotangent squared. Same thing, right? Commutative property for addition. So that is cosecant squared. So cosecant squared equals cosecant squared. Check. Verified. Proven. Ta-da! That's it.